Hi everyone, this is Dr. Brahmayya, Associate Professor, Department of SNH Chemistry, MLR Institute of Technology, Hyderabad. Today I am going to talk about electrochemistry and corrosion. Overview. We are going to cover Introduction to Electrochemistry, Fundamental Concepts of the Electrochemistry, Galvanic cell and electrolytic cell definitions, electrolysis and electrolyte. What are these terms in the electrochemistry? We will discuss. So in the introduction, electrochemistry studies the relationship between the electrical energy and chemical energy. Actually, this term in 1814, George Johnson Singer coined this term. So in electrochemistry, electro it involves current and potential difference, it involves in the current flow or electricity and electrode potential difference. And chemistry, it involves reactions, transformations of electrons and substance changes. Likewise, this electrochemistry involves both electricity and chemistry. So these are the interplay between the two terms. So it covers topics like electrochemical cells which convert chemical energy to electrical energy. For example, galvanic cell is just like battery, or use electrical energy to drive chemical reactions, electrolytic cells. So galvanic cell, in daily life we will see that batteries are the galvanic cells, and electrolytic cells which converts electricity into chemical energy. The key concepts include the conversion of the energy, spontaneous galvanic cells and the non-spontaneous electrolytic cells reactions. What are the spontaneous and what are the non-spontaneous reactions? We will see in the later stages. Faraday's laws of electrolysis and the relationship between the electrode potential and conditions through the Nernst equation. These are the topics always covered in the electrochemistry. So if you look into this figure, this is a zinc electrode, this is a copper electrode. Zinc 2 plus ions with zinc sulfate electrolyte, and copper 2 plus ions with copper sulfate electrolyte. So we will see what is electrolyte in the next steps. This is a KCl, it is a salt bridge, and the electrons transfer from one place to another place. So to which place to which, anode to cathode, cathode to anode, we will check in the next slides. Core concept of the electrochemistry. Electrochemical cells. These are devices that enable the interconversion of the chemical and electrical energy. So electrochemical cells are, one is galvanic cell, another one is electrolytic cell. Galvanic cells, they convert chemical energy to electrical energy. The best example is battery, and electrolytic cells are use electrical energy to drive non-spontaneous chemical reactions. So the reactions must need an extra force to drive to make a chemical reactions. That is non-spontaneous reactions. What are the spontaneous reactions? That don't need an extra force. They will transform electrical energy. They will generate electrical energy by chemical reactions, spontaneous chemical reactions. So electrolysis is one of the example for the electrolytic cell. H2 on electrolysis will give you H2 plus O2. It is a general reaction. So this is a electrolysis. It is an example of the electrolysis. Electrolytic cell example is H2O electrolysis gives rise to H2O and O2. Electrolyte. What is electrolyte? A substance that conducts electricity in their aqueous solutions, fused form, molten state due to liberations of the ions resulting chemical change. Any KCl or NaCl, if they are in a aqueous solution, if they are in a aqueous form, they will conduct the electricity due to the presence of the ions. Due to the presence of ions, K plus ions, Cl minus ions like this, Na plus ions and Cl minus ions like this. Difference between the galvanic cells and electrolytic cells. Galvanic cells and electrolytic cells are both electrochemical cells, but they operate on opposite principles regarding energy conversion and spontaneity of the reactions. So they both are opposite principles. They depend on the opposite principle. For example, energy conversion converts chemical energy to electrical energy. This is galvanic cell. Electrical energy into chemical energy. This is a electrolytic cell. Reaction spontaneity, spontaneous redox reactions, delta G gives enthalpy. Non-spontaneous redox reactions, delta G greater than 0 requires external energy. Power source generates its own electricity. In galvanic cells, it generates its own electricity. In electrolytic cell, requires an external power source, e.g. battery. Anode polarity. In galvanic cells, it is negative. Electrolytic cells, it is a positive. Cathode polarity, it is a positive. Galvanic cells, negative in the electrolytic cells. Cell setup. Half cells are separate, connected by salt bridge or porous disc. This is the major difference. And both electrodes are typically in the same container or same electrolyte solution. This is the major difference of the electrolytic cell and galvanic cell. In the galvanic cell, the both electrodes are separated by a salt bridge, and here in the electrolytic cell, there is no separation. Examples. Standard batteries. For galvanic cells, examples are standard batteries. And for electrolytic cells, electroplating and electrolysis of the water, metal extraction, and rechargeable batteries. These are the basic things. What is the spontaneous redox reaction? What is the non-spontaneous reduction reactions? In the spontaneous redox reactions, we don't need any extra force to drive the chemical reaction into energy and energy into electricity. Whereas in non-spontaneous redox reactions, delta G is greater than 0. It implies that plus. In Gibbs energy change, it is plus greater than 0. It is minus. When it is a delta G is minus, it implies that spontaneous reaction. Delta G is plus, it implies that non-spontaneous reaction. And delta G is equal to 0, it implies that the reaction is in equilibrium state. The reaction is in equilibrium state. So this is the electrolytic cell, this is the galvanic cell. We can see the major difference. This is the salt bridge. There is no salt bridge. Within the electrolyte solution, either copper sulfate or zinc sulfate, within the same electrolyte solution, the electrodes will be dipped. Whereas in the galvanic cell, the electrolytes are zinc sulfate and copper sulfate. Both are connected by salt bridge with two different electrodes in different containers. This is the major difference of the electrolytic cell and galvanic cell. Here the electrolytic cell is an external energy supplied. Here the current is generated in voltmeter. So key similarities. In both cell types, oxidation always occurs at the anode and reduction always occurs at the cathode. And the electrons always flow from the anode to the cathode through the external circuit. and both involve the movement of the ions within the electrolyte solution to maintain the charge neutrality. And in a sense, a galvanic cell acts as a power source like a battery, and while an electrolytic cell functions like a device that you plug into a force chemical change like a battery charger. These are the major differences. So we can see that what is oxidation? What is oxidation? Any metal ion which loses its electrons, it is oxidation. Reduction. What is the reduction? Gaining of electrons by any electrode. It is called reduction process. So we can, in detail, we can see further. So electrolysis, the process by which electric current is passed through a substance for chemical change. The substance either loses or gains the electrons, oxidation or reduction. The substance which can gain the electrons or which can lose the electrons, oxidation or reduction. That is called electrolysis. So in presence of the base, the equations are: cathode, water is divided into H2 and 2OH minus ions. It is ionized like, it is separated like H2 and 2OH minus ions. Anode, 2OH minus ions gives rise to half O2 plus H2O liquid and 2 electrons. So this is the electrolysis process. One substance is divided into H2 and O2. It happened as oxidation. This is the oxidation reaction and this is the reduction reaction. So oxidation, loses of electrons, and the reduction, gaining of electrons. So oxidation process is here. Oxidation is the loss of the electrons during a reaction by a molecule or atom or ion. And the reduction process is the gain of electrons or during a reaction by a molecule or atom or ion. It is the opposite of the oxidation. So here NaCl gives rise to Na plus Cl minus. So here Cl minus gains the electrons. It is called reduction. Whereas Na plus loses its electrons. Na to Na plus, it called oxidation. So it's very simple topic. Redox reactions. What is the redox reaction? Both oxidation and reduction can take place in any reaction, that is called redox reactions. So electrochemistry is based on reduction, oxidation reactions, which involve the transfer of electrons. Anode, the electrode where oxidation occurs. Cathode, the electrode where reduction occurs. For example, if you look into zinc anode and copper cathode, zinc gives rise to zinc 2 plus ions plus 2 electrons, whereas at cathodic part, Cu 2 plus ions will take these 2 electrons, Cu. This is reduction. This is oxidation. For example, one more redox reaction. An redox reaction is a type of chemical reaction that involves a transfer of electrons between two species. Redox reactions are comprised of two parts, a reduced half and oxidized half reactions. So in the reaction between the hydrogen and fluorine, for example, if you look into the hydrogen and fluorine reaction, hydrogen is being oxidized and fluorine is being reduced. Look into here, this is a hydrogen, this is a F2, become 2HF. This reaction can be analyzed as two half reactions. One is the oxidation reaction converts hydrogen to protons. Hydrogen will become protons. H2 gives rise to 2H plus ions plus 2 electrons. Whereas the reduction reaction converts fluorine to the fluoride anion. You can look into here, F2 gains 2 electrons, which gives 2F minus ions. This is a reduction reaction. These are the two half reactions. One is oxidation and one is reduction reaction. So this is the hydrogen and fluorine. They will react with each other in a oxidation manner and reduction manner. They will form HF molecule. Summary. In the summary, the presentation covers the introduction of the electrochemistry, definitions of the electrochemistry and electrochemical cell, electrolytic cell, galvanic cell, and electrolyte and redox reactions, reduction and oxidation. This is the complete picture of the introduction part of the electrochemistry.